Um, so in our lab module or our lab handouts module, you'll see that there's a whole bunch of documents. These first few, I'm sure you've seen in every lab you've ever done. Accuracy versus precision, error categories, expressing error, significant figures, those types of things. If I click on sig figs, for example, um, these are really just references for you. You can read through it, leftmost digits, no decimal point, all that good stuff. Rounding off things, all that. So if you have any questions on how to do stuff, you can refer back to these. These were made by the department, not by me. There is one called a lab report cover sheet. And so when we do our labs, how labs will work is on Thursdays, I will do the labs when we're having labs. I will show you how to do them. I will take you through the labs. I will provide you with almost everything you need to just do them. You can work in teams of 3, no more than 3, but teams of 3 if you know 3 people. I'll tell you if I don't want you to. Some of this stuff I want you to do on your own because I want to make sure that you know how to do it. But when you work in a group, I want you to make sure that you include in your lab report on the front page this cover sheet. So you can just download this and copy and paste it into your lab report. Once you do that, make just fill it out with the names of people. No more than 3. I'm sorry, let me actually reopen that. So this actually says, because when we do labs in person, we had these 3 roles that you would have a group and you would have 3 people, and one of you would be the researcher and the analysis and the analyst and the principal investigator. So really what that boils down to is when we do an experiment in the lab report, you'll have your data, which means that someone's going to need to do the experiment with the IOLab, or all of you can do it, and you can use the best data you have. But they'll need to fill out the data table, and you'll see as we go how that works. The analyst really will have to do the calculations of the error and the actual quantities that we're trying to find for that lab. So in free fall, we're trying to find the acceleration due to gravity. They need to figure that stuff out and do that calculation. I will provide in the lab handouts, I will provide all the calculations. So you're not going to need to figure that out so much. We'll talk about that today with some simple calculations. The principal investigator basically needs to write the questions and the conclusion. So what happens if you work in a group, a lab group with 3 people, and someone doesn't do their part? Well, number one, the first thing that I have to say is learning to work with people is part of doing research, and sometimes people don't necessarily do the best job. It's up to you to make sure that whatever gets turned in with your name on it, you're happy with. So please make sure that if you're working in a group, you see what's being turned in with your name on it, because if you come back and say, hey, we got a really bad grade on that, and it was because so-and-so did the calculations, I'm going to be like, did you look at it before it got turned in? Second thing, you'll always be able to fix it. So if someone does do the bad calculations, I'll let all of you know that we're on it, that the calculations were missing certain parts or something was wrong, and I'll allow you to correct it and send it back in. As long as it's above 90, I won't do that. But if you get like a 40 on it, you will have the opportunity to correct it, and I'll give you plenty of time to correct it. Okay. My goal is for you all to write really, really brilliant, great lab reports by the time we're done. So when you go to 4B and 4C or any of your other classes, you already know how to write really, really good lab reports. That's what I'm here to teach you how to do. That's why you're taking the class, part of it. But if the lab gets turned in and someone didn't do calculations, and you're like, hey, we never got the calculations and they're ghosting us, we've emailed them, they won't email us back, I will take it from there. As long as you've done the initial, tried to contact them, and you can show me. And I won't count it against your grade if someone decides they're not going to be in class anymore and they just leave you hanging. I won't make you do their work for them on that lab. Obviously, by the next lab, you need to figure something out. But okay. So just if you do work in groups of 3, make sure you fill out a cover sheet for me. It just helps me figure out who's on what. And then, sorry.
Professor,
Yes.
if we're working in pairs, do you
Yeah.
care how we divide up the workload or no?
No, I actually think that that's up to you guys. If you're working with just 2 of you, if you're working with 3 of you, no more than that. But however you want to divide the workload is up to you. Like I said, I don't mean to talk down to you guys at all. But if you've never worked with people, um, working with people is always kind of annoying sometimes, even especially if you like people. It can be hard. So you need to learn how to work with people, and you also need to speak up when you aren't totally happy with things. And you need to be okay if someone tells you that they're not happy with your part and they want it fixed. That shouldn't happen, but I don't, I want hands off. I want you guys to really work and figure that out. Some of the other teachers in their courses, they really get on you on your roles, what role you have. And you can always work solo if you want. You don't have to work with other people. But I will tell you that if you do solo, some of these labs are a little intense for the work. And I would worry that you might have a lot more work to do on a lab report than a group of 3. But I'm not going to demand that you be in a group. The only thing I'm going to demand is that you don't have more than 3. Um, but I'm not going to force anyone who doesn't want to be in a group to be in a group.
Professor?
Yes, ma'am.
And so with every lab that we do, we turn in that cover sheet out and fill out the sheet. So with every lab, we use that template and
Yes.
turn that in.
Yeah, and in fact, you'll see in the graphing handout, pretty much the handout I give you, you'll be able to use as a template to create your lab report. That cover sheet is just there if you have more than one person. It just helps me figure out who was in the lab.
Just so you know, like who did what part if you did it with 3 people.
Yeah, yeah,
Okay. But
yeah,
in general, we just turn in the template for the specific lab that we're working on.
yeah. You can
Okay.
just turn it in, and it's got your name on it when you submit, which I guess I should say. If you go into the assignment right now, there's already an assignment for Lab 1A, 1B. So you'll turn in the graphing one there. I would like them submitted as a PDF. Um, so if you can do that, if you can create it as a PDF in like Word, that would be most helpful. I don't know if there's other options, but I have it set up so that you can just download the files. So one of you, if you do it with 3 of you, only one of you needs to submit it with your names, and I'll make sure that I get the grade to everybody. But let's say Jack is working with 2 other people and it's only got Jack's name on it. I won't know who else worked on it, and I won't know how to give them credit. And then I have to get to Jack and ask him, oh, well, who worked on this? So the cover sheet helps me just make sure that I get the right grades to everyone. And as you'll see, there's going to be a lot of stuff that we do that we're going to learn. We're going to learn things a step at a time. And it may seem really dumbed down for the first lab or 2, but I'm doing that on purpose because some of you may never have done a lab before in physics or in science. So I want to make sure that I don't give you too much and overwhelm you. So today's labs are, 1, we're going to make 2 graphs with different trend lines on them and do a little bit of trend line examination. Mostly what's asked for is I want to make sure that your graphs look right. And what you need to think of is like graphs in a scientific paper. If you go read a paper, in any journal, that's what I want. And I'll show you how to do that. There's a standard way to do that. And we'll do it with some data that I have for you. And we'll fill out a table of results and we'll do a little conclusion and we'll answer some questions. It's all in the handout. I will take you through the handout. The other side of this is going to be the IOLab. And this part's a little harder, only because some of you don't have your IOLab. Some of you have your IOLab and maybe haven't done anything with it and don't know how to get it set up and working on your computer. So half of the IOLab is just helping you guys get your IOLab set up. Now, how I want to do this is I'm going to do the graphing lab first, show you how to make graphs in Excel. If you don't know how, I'll actually do it in real time myself with you guys after I go through the handout and try to help you guys live real time. So if you don't think you need help with the graphs, you just need to stick around while I go through the handout real fast. The IOLab, if we look at this IOLab, and I actually have it, right here in the IOLab handout that's at the bottom there, it says Lab1 IOLab. It gives you step-by-step this link of how to download the drivers and to get your IOLab up and running. Mine's already running on my computer, so I can kind of help you with it if you can't get it going, but hopefully we can get everyone's IOLab that has it working. Then what I'm going to actually show you is how to calibrate mine. And there's a little thing here that I just want to talk about. And then what we're going to do is we're going to actually use it to get some data and fill out a quick graph and quick calculation. And then there's a couple things I want you to submit. So after I do the graphing, we'll go through this IOLab thing. But if you don't want to do any of this with me, you are free to leave as soon as I get done explaining the handout on graphing, okay? So what you will need to turn in is on the graphing handout, there is, well, let me just open it for you. Let's talk about this. So basically when we make graphs in this class, there's a few things that we need to know, and I'm going to go through it with the actual data. But number one, when you add graphs in your lab reports, I want them either full page, landscape, or portrait, whichever way works. Or if you're going to print them out, you can actually put two in landscape orientation as long as they fill the whole page. So the top half will be one, bottom half will be another. We're going to make 4 graphs, so we're going to want 2 graphs on a page, both in landscape. We'll talk about curves when we actually put the data in. But the procedure is, so you can take this right here. You can write a quick purpose statement. You don't always have to write a purpose statement. Sorry. The graphs in the IOLab are actually 2 separate lab reports. Normally a lab report's worth 100, they're each worth 50. They really will take longer to explain probably than to do. They're both fast, but you need to submit them to their own assignment. What I want you to do is once you get to this part of the graph, short purpose statement, just what we're doing this for. Paste the data tables. Now, let me do something really quick. That in general, this might help you a little bit. So in general, a lab report consists of a couple things. It contains your data table, and this is the raw data that you collect. In this lab, I've given you the data table, so you just need to copy and paste them. It contains any graphs that you may have, including screen captures of data or whatever you need. It will contain calculations. So anything you need to calculate, including error. Next week, we're doing measurement, and that's really the error lab. There's no error associated with this lab today. There is a calculation, but it's a % difference, and I'll talk about that. Then we'll have a table of results. How are the data table and the table of results different? The data table is your raw data that you collected. Any error associated with your equipment, which we'll talk about next week. The table of results is the actual findings. So maybe you're trying to find, like today, we're trying to find a spring constant. We'll have the spring constant listed in a table with the error associated with our findings and anything else we need. Then in each lab, there are questions that you need to answer. You need to answer them in double-spaced complete sentences. I'm not grading your English, but I appreciate it if you write them as nice as possible. They don't have to be long. 1 or 2 sentences to answer each question is usually fine. And then finally, there's a conclusion. Now, you could actually move the conclusion to the top, but a conclusion has 4 parts. What you found, and when you report that, you need to give numbers. And I'll go through this every time we do a lab. I'm going to take you through all of these again. But it's always what you found, your error, numbers again. So let's say we find the spring constant today, and we find it as 12 newtons per meter. The error associated with that, we need to talk about. Sorry.
Is that like
Go ahead.
the error, is that like what you got compared to like what the theoretical was?
Yes and no. There's experimental error that we'll have, and we'll talk about that next week. Next week, we're going to measure a few things to get their volumes, and we're going to look at how the measurement works. And it's not the greatest or most exciting lab, but there's going to be error associated with the volume we find. So we might find a volume of, whatever, 10 centimeters cubed, plus or minus 1%.
Mm-hmm.
So that error would be that 1%. And I'm going to show you how to calculate that 1% error when you have multiple measurements. But you need to report the numbers. I don't know why I wrote where. What did I mean to write there? Sorry, my brain went off track answering your questions. So you need to report the numbers, the actual errors. Oh, I know what I meant. And where the error came from. So we're going to have like error due to our ruler, or you might have error due to friction if we're sliding on a ramp or free falling. So your best guess where those errors came from. There's 2 types of error. There's systematic. Systematic error occurs because of your device. So a ruler, when you measure anything with a ruler, there's an error associated with the fact that you only have certain resolution. Usually we'll have a millimeter ruler with millimeter marks. And so we have a 0.5 millimeter resolution. That's our error that's associated with any measurement we take with that ruler. We can't tell how good it is, beyond about 1/10 of a millimeter. That's a systematic error because it's going to be the same error with everything you measure with that device. Now, there's also random errors. And the problem that we have with random errors in this particular class is random errors are things that happen, but they're completely random. If you're trying to place a ball at a certain height, sometimes you're going to be a little high, sometimes you're going to be a little low, but over 300 or 400 measurements, that random error going to zero out and go away. So we're going to talk about our error, like, our volume of 3 centimeters cubed, plus or minus 1%, and that our error came from a ruler. It's systematic error due to our ruler. That's all I mean. The last things that you're going to do is talk about ways to minimize error, usually. And then something that I call next steps. So if you haven't read any scientific papers, this is generally how a scientific paper presented in a journal. They give you their data. They generally introduce it. I don't want you to introduce any of these labs. Some lab instructors have you basically rewrite the whole experimental procedure. I don't want you to do that at all. But what I do want you to do is talk about your error. Imagine that you would do this experiment again. How would you minimize that error? How would you make it better if you could? And then next steps is how would you make the experiment better? What else could you do to learn more from that experiment? So for instance, we're going to do free fall. And one of the things that Galileo showed was in a vacuum, it's mass independent. The acceleration of gravity is independent of the mass. So we could try and make an experiment that showed that by using different masses, let's say. That would be something. But we'll talk about that every time. And I'll take you through these every time. Another thing that I do need to talk about, and this is a side note, but one thing that they always kind of give us a little bit of a knock at IBC, and what I mean like UCs and CSUFB, is I've heard that they get mad that our students don't write very good lab journals. So if you want to keep a lab journal, my thoughts on lab journals, if we were in actual lab, I would have you all writing down in a journal your data, the data you collect. I've done experiments, and I'll tell you this, how it worked for me when I was a grad student in my lab or in my faculty advisor's lab was every experiment I did, I had it running to a computer and the computer was recording the data. But every 5 minutes I would walk over and I would record whatever the instruments were saying. I had like experiments that would take 2 hours. So I had a record, I had a handwritten record. The reason why I had that is, what if someone walked over and kicked my computer and knocked it out of the wall and now I have no data on my experiment? Or if the power went out, you never know what could happen. So you could have your computer and leave it on the bus. In the real world, you're going to want to have a backup, a hard copy that can't be erased for your data. I mean, you're doing important work, you're doing research. So what your lab journal should have is everything that you can possibly write down that matters to you for that experiment. Maybe time of day, maybe temperature. And it's also your private diary, meaning that if you mess up the experiment, maybe write down, oh, I forgot to add, the correct amount of, potassium iodide to the solution. And next time I need to make sure I'm careful, or I think maybe something went wrong here, maybe I should try this. So I'd have little notes to myself of what I wanted to do. I would also put notes on like things I was going to do the next day when I came in. Being a grad student was a little weird because you don't really have a lot of supervision. You're kind of doing your experiment and checking in and telling your instructor or your faculty advisor what you've been up to and what you're finding. So some days, I would just try different weird things, try things and see if I learned anything new. So in a lab journal, generally what you do is you write the date, any parameters, time of day, temperature, what solution you're using, if you've numbered your solutions, all that good stuff. And you write a handwritten copy of data. That way, if the file gets corrupted or destroyed, you're not relying just on a computer. You always have a handwritten backup that you can show. You might work at Intel and they might ask you to do the same thing. I'm not going to ask you to do that. For me, it's enough that you have your data table. But if you are in a lab, it's a really good habit to write down by hand. All of you write down your data together. Basically what would happen is you would write it on the data table and pass it to the other 2 people in your group anyway. So why should I make you write it in a notebook and give it to me? But just know that. If you want to choose your partners, that's fine. I'm not going to make you work together. And if you guys want to use the chat to ask people if they want to be partners. That's great too. I'm going to get rid of this for now. Okay, so what we're going to do is I have some data for you, and I'll show you that data in a minute. We're going to make 4 graphs in Excel. A graph always has to have, this graph doesn't, but it'll always have axis labels with units, and I'll go through that when I do it. It always has a title. The title is usually, if the title is like pressure versus time, Pop, come here. If the title is pressure versus time, if it's Y versus X, keep in mind that the first thing, in this case, the pressure versus time, pressure, whatever comes first is on your Y-axis. So if you have a graph, the Y-axis is what comes first versus the X-axis, okay? You can easily mess that up in Excel and have your graphs flipped. Now, usually the reason why we graph our data is we want to get a relationship between Y and X. On a linear graph, the slope of that line is actually the derivative. It's the rate of change of Y over X. So usually what we're looking for is some kind of relationship between Y and X. Hopefully it's linear. It may be polynomial. It may be cubic. We'll go over that shortly. You're going to make 4. For the first 2, we're going to use the first data set. So let me open up that data set really fast. Is that, yeah. So here's our data. And you can see that I have here, I have pressure, and then I have trial 1, and I have trial 2. So we're going to do a P versus T graph where we're going to have pressure versus temperature. Pressure will be on the Y, T1 will be on the X for graph 1 and 2. T2 will be on the X for graph 3 and 4, okay? Now, I don't know why this happened, but it's fine. So let me open up an Excel. If you guys want to open up Excel, if you don't have Excel, one thing that I need to tell you, so Excel does not have a way to get your error associated with your slope right on the graph. I don't know about Google Sheets or some of the other programs on there. When we're at IBC, we have a really nice computer program that will give you the error associated with your slope. There is a way, it's called LinEst. I'm not going to do it this week. I don't think I'm going to do it next week, but the week after, when we do free fall, we're going to get the slope and we're going to need the error associated with it. And I'm sorry, my dogs are being super annoying because they want to go outside. So one other thing I should note that I did for you, if you go back to our Canvas, there is a PDF on making graphs in Excel that will take you through all of this as well. I'm going to do it right now live for you, but it's there if you don't know how. One thing you can do is, I'm not sure if this will actually do it correctly for me. So if it doesn't, I'm going to have to figure it out. You might be able to copy and paste. Yep, cool. So it worked. This is my P, this is my T. One thing I would suggest is moving this one over. You can go in and actually tell it, you can do a bunch of stuff where you can tell it which columns to use for your graphs. I don't ever do that. I generally just make a couple separate sections, and I'll show you what that means in a second. So Eric said Google Sheet can give a regression line if that helps. I think it can also export as an Excel file. Yeah, I'll show you what I'm worried about with Google Sheets that I don't know. So we have our 2 sets of data. This is trial 1, which I should really put trial 1 here, and I can put trial 2 here. Now, here's the thing. If I've done this right, I highlight my data, so I'm going to highlight this data first. I go to insert, I click on graphs, and I click on scatter plot. Okay, I've got that backwards. I always forget on Google Sheets. I'm sorry, on Excel. Again, I could go in and I could change what's on the Y and X. There are actually controls that will allow you, when you do the insert in the graph, to pick what's on what. I just find it's easier just to flip them. So my first 2 graphs are going to use trial 1 with this pressure. Notice that pressure is the Y, and so it's the second column. We do not connect data points. The reason why we do not connect data points is they are not, in general, a continuous spectrum of data. All these points are discrete points. So make a scatter plot, do not connect them at all. So once I have this, there's a bunch of stuff I can do. In the older Excel, you could do it with a little like plus tab here. On the newer one, it's here, add chart elements. So add the axis titles. This is, what did I just do? Axis title. This was our temperature in Celsius, I believe. Always make sure that you have your units in there. I can just, let's see. And then add element. I can put, this was pressure. Now pressure is in pascals, which is, I know I didn't do a great job spelling that. So pascals are capital P, little a. Those are the units of pressure. Add a title above the chart. I don't care what you call this. I'm going to call this ideal gas law or non-ideal gas law or whatever. Ideal gas law. Okay, so now it's okay if you're falling behind. I'm recording it, so there are instructions on how to do this, and it'll be uploaded tonight. It'll all be on there. Plus, there is a handout that shows you how to make these. So here's the part you got to pay attention to, though. Trend line. So we want 2 graphs. Hang on one second. Bro. Come here. Puff, treat. Come here, Puff. Maddie. 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 Come on, man. Maddie, come on. Go. Come on. Okay. So what I want you to do is, yeah, one of them's my son's dog. So when he's here doing his school. He doesn't live with me. The little pug is the German Shepherd's my dog Puff. Anyway, so we're going to do 4 graphs. So this was graph 1. You might want to write in here trial 1. We're going to make a graph that is quadratic and a graph that is cubic. Okay, so for trial 1. So let's call this quadratic. And then when we do our trend line, what quadratic is you want a exponential trend line. And let me, when you go to trend line, go to more trend line options. And I should have really taken that out. Go to more trend line options. And you're going to select polynomial. Order 2 is quadratic. Order 3 is cubic. It's the order is the highest power. So order 2 means it'll be x squared plus some coefficient times x plus a constant term. I want you to do, and this is super important, always display the equation on the graph, and display the R squared value. Now there is something called the R value and the R squared value. There's also the RMSE value. What the R squared value is telling you is how close your points are sitting on the line. I cannot emphasize this enough. R squared, to actually have really good correlation with your data, needs to be at 0.99. That means 99% of your points need to be on that line. I can, and you might not be able to see this, so I'm gonna, don't do that. I want you, so I'm gonna move this. I don't know why this thing won't. Here. If I go to home, I believe I can change it to 16 maybe. Nope. So this R squared value is 0.98, which isn't great. If it was 0.99, it would be better. Last thing I want you to do is, if you have a Word document open now, which I do here, I'll just put it here at the bottom since I have this one open. What I would do is have a Word document, go back to your Excel. I know I have a million. Click copy, go back to your Word document and paste it. And when you paste it into your Word document, I want you to have 2 of these a page. So make it big enough that you can see it on the top half of your page. I would suggest doing that. And then what's really nice, since you already have this data, you can just go back in and change it to cubic. Cubic, and go to insert. Formulas? Nope. Where did you go? Chart design. Under chart design, make sure that you change the trend line under more trend line options to a order 3 polynomial. If you end up with an extra I don't know why it's doing that. I always have a problem with it doing this, where it gives me 2 different trend lines. I'm trying to remember how to get rid of that. There it is. So now that it's, nope. Sorry guys, none. Then go back into trend line and trend line options. Display equation, display R squared, polynomial, degree 3. There we go. Move this R squared and trend line somewhere. Make it bigger so that you can actually read it. I don't know why mine's being weird about that. Now you can see that with the cubic, it's actually over that 0.99 threshold for the R squared value. So a cubic trend line actually represents this data fairly well. Same data that we used. Now that you have the cubic, take that, copy it, go back to your Word doc, paste it. And so now we have our 2 different trial 1, and then do the same thing for trial 2. I don't know why it moved it. If you can fix it, oh yeah, I can fix it right here. Try to fix it so that you can see it. I don't really care as long as you can see it on the graph. But once you have this for trial 1, do the same thing for trial 2. Then you're going to go to your table results, which are the graph comparisons. And this is going to say first and third. So when I go back to here, I can cut this. I can now select this data. I can make a graph with this data. Scatter plot. I'm not going to bother putting the axis labels on mine, but make sure you put them on yours. Make sure the pressure is on Y, the temperature is on X, as before. And then I'm going to add a trend line. This is obviously my second. Why did you not do that? Trend line, more trend line options. I'm going to add a second order polynomial, display equation, display R squared. So let me make this as big as I can so that you can see it. Okay. Now, it says quadratic coefficient for the first trial, the A value. So that is the one associated with X. So all you need to do here is put 122.68 and the linear coefficient is the one associated with the single power, so minus 6136. And then the constant coefficient is the one with no X, so 97174, right? Then below that, I want you to put the ones from here, so 16106. And I'm not going to do all of them. I'll let you do all of them on your own. But you just need to put the coefficients from these trend lines. For the cubic, the D coefficient is always the one that has the X to the third. The C is the X squared, blah, 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 blah. So you're going to fill out this data table with all of those things. And you're going to have your 4 graphs. The 161 that I put here came from my other trial, from trial 2. So when you look, you're going to make 2 graphs for trial 1. One will have a quadratic or polynomial power, second power, polynomial to the second power on its trend line. Chart design. So you're going to make one graph with a polynomial of order 2 and one graph with a polynomial of order 3. Only one of those trend lines on the only one of those trend lines on the graph at a time. So when you're done, it'll look like this for trial 1. You'll have a quadratic and a cubic trend line. Cubic means that the highest power is X to the third. Quadratic means highest power is X squared. And then put your coefficients there. Once you've done that, I can go away from this. I can get rid of this for you. Don't save. Once we've done that, you have a table of results. And this handout just tells you how to go through. That's the data table, sorry. Can't see. So you also have in our Canvas, you have a data table and table of results, which gives you this data. And incidentally, there's the making graphs themselves. In the table of results, you have calculations, and I'll talk about what those are. And then you have these tables. So what this is the quadratic, the X squared coefficient for the first graph for trial 1 and the first graph for trial 2. I want you to compare them and get the percent difference. What is a percent difference? So let's say that I want to compare everyone's test score. I want to compare Jack, and I'm sorry, Jack, that I'm using you, but Jack and Lucas's test scores after exam 1. What I would do is I would write them. Let's see if I can actually draw on this. So let's say that Jack had a 20 and Lucas had a 16. All right, so this is J, this is Lucas, and I want to compare them. Well, I can get the average by adding them together and divided by 2. So I could get J plus L and divide by 2. And that would give me 36 divided by 2, so 18, right? If I want to know how different their 2 scores were, and then average it as a weighted average, no, not 16%. Say the test was out of 20, you got a nice 80. So if I want to do the percent difference, so the difference between them as a percentage of the average, what I have to do is I have to subtract them and divide by this average, J plus L over 2. So that would be 20 minus 16. So that would be 4 over 18. This would be 2/9, whatever 2/9 is. So 2/9 is 0.222.
So it's the difference divided by the average.
It's the difference divided by the average. And I don't know why my, it's so weird. Sorry. I don't know where my,
And then just to make sure, we're supposed to have 4 graphs. So for trial 1, we need a quadratic and a cubic graph, and then same thing for trial 2, right?
yeah, I'm sorry, you guys, my mouse just decided it didn't want to work. That sucks. Let me go grab a mouse really fast. Hey, Si. Oh, I'm sorry, you guys. So what is sorry everybody about that. I don't know why my mouse died. So yeah, the percent. Okay, so let me answer your question really fast, Sammy. I'll go back to that in a second. In the first trial, if I get rid of this, cut. This is the first trial data, Sammy. If I insert that and a trend line with, why did you not do that? With a polynomial, degree 2, display it on there. So this is the, this is for trial 1, right? If I go through and do trial 2, and I put a trend line, so for trial 2, Sammy, so this data set, the x squared coefficient is 161.06. That's where I got that 16106 from. Does that make sense? Hopefully. I don't know if Sammy can hear me. Cool. Okay. I just didn't want you, yeah, no, it's fine. I just didn't want you to be confused. I really don't want anyone confused. So once you do those though, so once I have these two, what I want to do is I want to compare them to each other. So remember that this one is trial 1 and this is trial 2. Let's say I want to compare the x squared coefficient, 122.68 to that. Now, when I give you the calculations in the handout, I will give them to you like this. I want you to keep the equation, the theoretical or the symbolic equation, but then you can just fill these things in. So A1 will be trial 1, so 122.68. So I will put in 122.68 minus 16106, 61.06, and then this part is adding them together and dividing by half, which is the average. And then once I do that, I can put it in my calculator. So in my calculator, I get 122.68 minus 161.06 divided by so I get 0.27. I actually get a negative. These mean absolute value. So I get 0.27. If I multiply that by 100%, I get 27%. So there's a 27% difference in between the two in relation to the average. Okay, so here's a quick, I don't know what that was, side note about this. When you only have, girls, when you only have 2 data points, this makes no sense. Why? What if one of these was 0? So let's say instead of this, this was 0. What do I get? I get 200%, right? Because dividing this, I basically get 200%. So you get 200% out of that, which means that doesn't tell you anything, right? It doesn't work when one of the values is 0, when you only have a couple of data points. Be aware of that. What does this tell you? This tells you how different 2 numbers are that you don't have a theoretical value for. When I talked about the test scores earlier, if I take all the test scores, I wouldn't have a theoretical value for a test score, right? I wouldn't know what the average should be in class. So I use the average, and then I take the difference. In effect, what I'm using is one of them as like the score I want to compare. I'm just comparing 2 scores. So I'm comparing how different their scores were, but I'm dividing by the average so that I can get a percentage. So I want you to do that for the quadratic, the linear, and the constant coefficient. The coefficient on the x squared, the x, and the constant term for the first and third graph. For the trial 1 with a quadratic trend line, trial 3 or trial 2 with the quadratic trend line. I want you to compare those 2. After you've done that, write it here as a percentage. Then do the same for the 4 coefficients for trial 1 and trial 2 on the cubic graphs, okay? So you're going to compare them. What should they look like? Should they be close? No, they're probably going to be really far apart, and that's okay. You're just practicing taking percent differences. In fact, I believe one of them may not even have one of the terms, and that is a really important point. If you do not have a term in the percent difference, so let's say there's an x squared term for trial 1, but trial 2's trend line doesn't have an x squared term. Do not write 0 on the percent difference. It is not 0, it doesn't exist, which means you'll write not applicable. If one of them doesn't have one of these coefficients, then there's no way to do the percent difference. You can't just write 0. And I want to make sure you know that, okay? So now, hopefully that all makes sense and that's not too hard. Once you've done that and you have your 4 graphs with all the axes labeled, the title labeled, the trend line, and the R² value on your graph, and you filled out those tables, I want you to answer these questions in complete sentences. Question 1, R² is a measure of how close the data fits the trend line. The R² value has a minimum of 0 and a maximum of 1. For us, anything better than 99 is accurate. If it's less than 0.99, even if it's 0.98999999 forever, then it is not an accurate trend line. Based on this, I want to know which of your graphs are accurate and which aren't. Obviously, the cubics will be accurate. I don't remember if the second data set's cubic even is accurate though, is within that 0.99 or better threshold. Secondly, the second question is this graph. I want you to identify everything wrong with it. Number one, you do not connect points ever. Number two, there's no axes, there's no units, there's no title. I have no idea what this graph even represents. I could probably try to figure it out based on the numbers if I knew what data they were talking about. So I want, in complete sentences, mention the things that they didn't do right. What did they do right? Now that's up to you if you think that they did anything right in this image here. And then finally, I want you to write a conclusion. In the conclusion, I want you to compare your 4 graphs. Talk about things you noticed, talk about the R-squared values, talk about how well the coefficients match, or if there's really interesting differences in the coefficients and why that may be. Really what I want you to notice is the higher the power of the polynomial, the better the fit, right? But so you're gonna have, basically, you could take this and you can plug in for each part, the data table, the graphs, the answers to the questions. You can basically just take this and plug in what you need here. So make sure that you answer everything. You should have the data tables in your lab report. You should have your graphs in your lab report. You should have your table of results. You should have your conclusions, or I mean your calculations. You should have answers to the questions, and you should have a short conclusion. Short conclusion, what I want is 3 or 4 sentences, maybe 6 or 7 or 8. You don't have to write a whole page. Just answer the question for me in complete sentences. Next time, we're going to talk about error. So we'll have more to write in our conclusion. In this one, I just want you to look at the graphs and compare a quadratic to a cubic. Does that make sense, everybody? If you have any questions on that, please let me know. You can find the data table here. You can find the table of results here. You can find this. Yeah, if you do it in Word, you can easily write a PDF. You don't have to do it in Word. You can do it in whatever Word program you want. You can do it in whatever Google's called. I forget what that's called. Maybe that's Google Sheets. I don't know. But this will take you through making a graph in Excel with the new Excel, the one I used. Yours may be older, and if it's older, the one big change is when you go to make the graph, the trend lines, there's a little plus button to the right of your graph that you can click on. But just make sure you know how to make them, that you add them, and it shows you everything in here on making a graph in Excel. Once you have your lab report written, save it as a PDF, go to the assignment and the graphing assignment. And yeah, I'm going to go over the IOLab right now and post it there. For the IOLab, now I have mine plugged in already, so some of this I'm not going to be able to show you. But in the IOLab device, I'm sorry, the IOLab lab handout. Let me actually just stop this right now. Nope, that wasn't what I wanted. You can open it. Okay, so once you have your IOLab, the back of your IOLab has a little, it looks like a thumb drive. Take that out and insert it into your computer. If you go to this link that says Higher Ed, it will take you through preparing your IOLab. It'll let you install the software for Windows or Mac, whichever you have, and calibrate things. No. You don't have to submit it today. You need to submit it by Thursday midnight next week. So those files, that data that I used is the actual data that you have, Rachel. And you have a week to do it. I think it's 8 a.m. Let's double check really fast on that. If you go to the IOLab instruction flyer, yeah, it's 8 a.m. It says for tomorrow, 8 to 4 tomorrow. And you go to this, go in through the south entrance. I think they're actually going to take you before lot 7. Bring the IOLab loan agreement, fill out everything but the kit number on there. So there's some stuff you need to fill out. You don't need to fill out the kit number. That's so that you can just hand them that. They can hand you the device and you can get out of there. And there's less of a chance of you getting COVID, obviously. So this whole thing will take you through how, yes, bring an ID. If you know your ID number, but you have like a driver's license or a ID, you can just bring that and give them your number, but you need some form of physical ID. Okay, is there any other questions about picking up the IOLab if you haven't? Okay, so once you do have that, if you go into the modules, yeah, the form has to be physically given to the attendant out there. So go into the IOLab handout. I clicked on this link here and it took me here, and that's where your drivers are and how to calibrate. I'm going to show you how to calibrate mine, how to run it, but and how to view data once it's all up. Okay, so you should be able to get it up and running, I hope. If anyone has any problems, I can try to help you walk through it and go through it. Make sure that your IOLab has okay batteries. I think the same batteries have been in them for 2 semesters. So if the batteries are worn out, you can unscrew the back and there's a battery case there. Try to be gentle though with it, because if you're not gentle with it, you could end up breaking it and you might have to pay for it. But I had a student who couldn't get the little dongle thing that they call it out, and had to kind of work at it a little. Anyway, there's a little bit of a process that you may need to do to install things. It'll take you through it in this video. The lab write-ups are always typed yes. Please don't write in pencil. Sometimes people will do the calculations in pencil, and I'd rather you just do them in Word, because I give you the actual equations. All you really need to do is copy and paste them and fill in numbers. I like them to be typed yes. Okay, so this video, I'm trying to remember where the video, I believe it's, yeah, there's an article. You can't get the flash drive out. It just flips up. Don't be too gentle with it. I've had a few that were that way.
On the like metal part of it, it says press down, and then the back part of it will pop up.
Thank you, Lucas.
Yes.
So this preparing your IOLab video will help you get started. I'm not going to play it all the way. Well, I mean, I guess I can.
Let's open up the box. Here we have the IOLab device itself, a little bubble wrap, a screwdriver. We have some accessories. So the screwdriver is useful for opening up the back of the device if you want to put in new batteries. The battery cover is that thing with a screw in the middle at the back. Let's have a look at the accessories. Okay, so first of all, there's a piece of yellow foam. We can put that to the side for now. We can talk about that later. You probably won't need it. Then we have some springs and screws and things that are useful for some experiments. So we can get back to that as well. Then we have 2 pieces of felt that have sticky stuff on the back with a protective paper cover. So if you peel off the paper cover on the back of these things, you can stick these felt pads on the back of the IOLab device one at each end, and I've already done that to this one to save a little time. You can see it there, those two things. And the purpose of that is that the device slides nice and smoothly on your desk.
So once you pop that out, got that out, all that good stuff, there's a lot of stuff on the Macmillan support that you can look through. In this thing, I just talk about some of it. As I said, if you're having an issue, let me know. There's also here a nice lab from the University of Illinois, if you want to see how someone else did a lab right away, like this week, before we actually get to using it, because we won't use it for probably 2 weeks after this. Now, there's also a video here about calibrating. I'm going to show you how to do that right now. Number one way that you'll mess up your IOLab, or number one issue you'll have, is by not powering it up. There's a power button on the front. Make sure it comes on. There's 2 yellow lights. Once you have it on, if you go to the settings, the little wheel, there's calibrate. And what you want is you just want force. So let's calibrate the force. It says, put the eye bolt in. The eye bolt is the little circle screw on the bottom. Make it snug, don't make it too tight. Hold it, I'm sorry. It says to set the device on its head as shown in the picture and hit next. And then to lift the device and then hit next. Okay, and then you can save it, and that's fine. That doesn't mean that it's zeroed out, unfortunately. What I want you to do now, and this is shown in the IOLab device, is we're going to calculate the spring force constant associated with our spring. Which spring am I talking about? There are 2 springs in there. One is very short, one is very long and stretchy. I want you to take the long one. I want you to put the IOLab eye bolt, the circular eye bolt, in the end. Put it so that it's wheels down and connect that spring. And we'll do this in a second. I know you can't see exactly what I'm doing, so I'll hold it up and kind of show you. But once you've done that, click on wheel. You should have a very short spring too, Jack. Looks like this. I don't know if you can see that. It's a very short, tough spring, and you should have a long one. Do you have both, or you only have the one? Click on force. Okay. Oh, shoot. Dun, 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 dun. Okay. Remind me of that when we do momentum, that you don't have one, and we'll figure something out for you. Okay.
Okay.
All right. So click on force, click on wheel position, and that's it. Re-zero your sensors. Make sure your sensors are re-zeroed. Now let's look at a few things. At this point, we have a force graph. We have a wheel graph. This is the sample rate. This means that we're going to take 200 hertz a second. This is the wheel position, and the wheel position is going to take 100 hertz, which means it's going to take 100 data points a second. Notice those 2 things are very different, but we have both of them. Next, you have a record, reset, add run. You have a graph button, you have a zoom button, you have a pointer button. I'll get to those. These allow you to do stuff with the graphs. If you click on that one, we now have force and wheel position on a graph. If we swap it, we get wheel on the Y, force on the bottom. We get wheel versus, or position versus force. We want force versus position. I'll show you that in a minute. You can also save your files. You can do the cloud. You can calibrate. You can do all sorts of things. What I want you to do is, once you have the force and the position sensors on, So take your IOLab, make sure it's wheels down, hold one end of the spring, click record, and then just pull it. Why are you not recording? Probably because you're not on. Stop. Oh, because I'm a moron. Okay. So let me reset. I'm going to go back to the graphs. I'm going to hit record and just pull it back and forth so that you get kind of some nice sinusoidal waves as you hold the spring in one hand and move the IOLab back and forth. The nicer the better, but they don't have to be great. Then stop. Now select an area where you got some nice sinusoidal, meaning up and down, and click on the graph. Try to grab an area that had some nice, why are you, do I need to do that? What are you doing? Huh. Why are you not? Huh. Oh, there we go. Okay. So now you can see it. You got to be in the right area. So you can kind of see where I'm going back and forth. If I start here, you can see it going back and forth on the position and where I left it sitting. What I want you to do is get a nice area where you have a nice back and forth. So I'm going to actually go maybe here to there. I'm not sure if I like that one. Yeah, my data's just not great. And I can always try again. I'll just use this. Okay, so once I have that, what this is showing is, and I want to swap axes, I want force versus position. So that's a lot better looking. Okay, so I have this graph of where the position of the IOLab was at and the force. And remember that I zeroed them out, so I just let it move back and forth from the zero. Now, once I have this, how am I going to use it? I'm going to do two things. If I go down here, well, when I come back, I'll come back to it in a minute. Go to the pointer. I'm sorry, go to the zoom tool, which is the pointer, and find the first point. Okay, that first point, if you look at the top of this graph, it's giving me X and Y. And it says X is 0.006 and Y is 0.6787 newtons. Okay, so in the IOLab, I want you to write down 0.1. So the first point, the furthest point to the left, let's go 0.0072. And actually what I would probably like you to do is just screen grab this. If you can, try to get as close as you can. 6787, so I'm gonna put that back. This was 0.0070 and this was 6787. So they have the units on this chart, newtons and meters. Then come to the end, I'm going to use the bottom as my end. So 0.0792, 0.0792 and 2.1539. Let me write those down. I really should have written them down. 17. I don't have anything to write.
Force is negative, right?
What's that?
The force is negative.
Yeah, the force is negative. And I should have probably put that on here, huh? Yeah, and you'll see why in a minute. So I had negative 2.1744, and you will have totally different numbers. 0.0792. Okay, and then average force constant. So we don't know this yet, maybe you do, but for a spring force, the force is something called negative K, K is a constant, times X, or some constant times the position, how far you stretch it from its equilibrium or rest length. So K is therefore equal, if you divide by X on both sides and multiply through by a negative, K is equal to negative F over X. The average value of K is equal to negative F2 minus F1. So you take 2 points, the second point minus the first point, divided by the second position minus the first position, and you'll get your K average. So take this, copy it, and hit return, paste it, and then plug in your numbers that you got up there. So I got negative 2.1744 minus a negative 0.6787. And then this was 0.0070. And I believe that was actually negative, right? Yeah, it was negative. I'm not being careful right now. So negative 0.0070 and 0.0. Nope. Sorry, I switched those. It's 0.792 minus a minus 0.0070. Now, what is the leaf digits we have? We have 4 or 3. So we should have 3 significant digits. Put it in your calculator. 2.121. Yeah. That seems off for some reason. Why is that off for some reason? Negative 2.1744. That seems off. Let me try and do this again. So let me put that back. I can reset, make sure that your power is back on. If you're not getting anything, turn your power back on. Go ahead and hit record. Let it come back, pull it, let it come back, pull it, let it come back, stop. Go to your graph, select a nice region, preferably with a few lines. Use your pointer tool. I get 2.5997. 2.5597 with a negative sign, N, and 0.1275. And then down here, I have 0.7899 and 0.0078. Okay. Oh, and I need to swap those. So I'm done. Oh, I need force versus position because I want F divided by X. I'm sorry I'm making such a mess of this right now. So I get 0.0057 and negative 7.761661. And for my second point, I get 0.1261 and negative 2.57. So let me try this again. Point 1 position was 0.0057. And point 2 was 1267. 661. 25751.
Professor, what was off about it?
I know the number that it should be, and
Oh.
I was getting a factor of 10 off, so I know I did something weirdly wrong. So this should be force 2, which would be 25751. Obviously, too, I'm not being as accurate as I probably should be. This would be point. And I'm sure when I go back and watch the video, it'll be that I made some really dumb error. But okay, so I get negative 2.5751 plus 0.7661 and divide that by 0.1261 plus 0.0057. Yeah, okay. So now I'm getting a negative, but there's a negative in front. So I'm getting 13.7 newtons per meter. You should get a positive number because there is a negative in front. The K coefficient should be positive. I'm going to write that right here. You could write it there if you want. If I look, this has actually only got 2 significant figures. So I should really just call this 14, the least amount of significant figures that I know are 2. So 14.
But don't you have to compute subtraction first? Because you're subtracting in the bottom and you would still get 3 sig figs.
When I subtract the bottom, this number right here only has 2.
Right, but when you're subtracting, it's by decimal place, and that if you
Oh, is it? Oh, I see. I always forget sig figs. So if it is, well, let's actually go back and look at that.
the subtraction and addition is the least decimal place, and then
Okay.
if you subtract that, you're still gonna get 3 sig figs.
Yeah, I'm being dumb about that, huh? I always assume it's still, yeah. Thank you, by the way. So, computation, rounding off, addition and subtraction, 2 or more numeric, round all measurements to the same decimal place, proceed. Okay.
It might be I mean, that's what I learned in chemistry. I don't know.
No,
if
I
it's
think
the
you're right. I forgot about the decimal place rule, which is why I'm going back to look at this. That's what these are here for, to give us something to reference when we don't know.
Is it the same in physics as in chemistry?
It's the same in all science.
Oh,
Yeah, it's just the way you do a lot of these things. So, so yeah, keeping just the least decimal place here would be to the 4th. So,
oh yeah, it's 4 sig figs. Never mind.
yeah, it's 4 sig figs.
Yeah.
So this is 13.7253. I guess, although it would be 4 sig figs.
7.3.
Yeah, so it's okay. So let's go to 73. Okay, so that is our spring force constant. We will actually need that way later. You could write that as 1.373 times 10 to the, you're right, this is 1.373 times 10 to the first power if you wanted. Generally, I don't. When it's a number like that, I just leave it alone. If it was like 1373, I would write 1.373 times 10 to the third. But once you have that, the only other thing I want from you is go back to your IOLab. If you don't know how to screen capture, I believe it's Shift Command 5, or is it 8?
You can look up screenshot on the search toolbar.
Yeah, I always forget. It's Shift Command. I have a Mac, and I always forget which one it is. Oh, there it is. Shift Command 4. I use Sniping Tool on Windows. Once you do that, it gives it to you here. You can save this file and put it into your. You can put it into your report for this one. Which what I want for the report is I just want you to fill out the 2 points on this thing, and the 2 points on this thing, and I want you to calculate the K value. And then I want you to get a screenshot of your actual experimental data graph, force versus position. And the last thing I want you to do is go back to the force and position graph. Here, if you go to export to CSV, it tells you where it exports it. You can export both of them. You only need to export one. No, you're only going to have 2 lab activities this week because I wanted to get you started on the IOLab, and I want to make sure you know how to do graphs in Excel. But make sure you know where this thing got saved. It says that mine was saved in documents. So if I go to documents, I have IOLab work files. I believe it's in export. Yeah, in export. Click on your file, pull it up. I don't know why it's not pulling up. Now, this is the CSV file. This is the actual data that your IOLab took. These specific numbers all mean different things. For instance, I believe this was my force, right? Was that what I used? Yeah, this was my force gauge. So I can see the time, and I can see sample, I can see all sorts of cool things here. Where is my raw data though? So here's my raw data. So beginning at certain times, it's actually giving me different values of my force sensor, okay? And it's giving me the time that the device registered. So you have a time and you have raw data in different, in your different columns. So this call column is actually your data. The time is the device time. So the device started counting at frame 10, index 0. The only things that matter are time and call though. So let me go down to somewhere here. Let's say I could click on this, take this, copy it, and put it into Excel, and then I can graph that. The reason why I would want to do that, I can also, again, do this, and I can get my force gauge numbers. The reason why I'd want to do that is when you go to your IOLab and you go to graph, it doesn't really give you much, okay? If I go back out and I look at the force and I select an area, I need to be on the tool. If I select, for instance, this interval, notice a couple things. It's selecting the interval here, but the interval is also on the graph below. So all the graphs select the same interval, and I could actually have the velocity and the acceleration. It gives you that interval highlighted in every single one. It tells you, so you can see when I'm moving the time and the value, it's giving me that when I'm moving. When I'm not moving, it gives me the duration of the highlighted region. So if I unclick this, the longer I make it, I can get the time duration. This mu, this little U with a front tail thing on it, that is the mean value for the highlighted region. So it will give you the average value. It will give you this little omega. I believe that's omega. I always forget which one that is. I think that's omega. It gives you the standard deviation. So it's giving me the standard deviation, it's giving me the mean value, and it's giving me the time interval, sigma, yeah, of my data that I selected. That's really important because what we're gonna have to do is whenever we use the IOLab device and we have a whole bunch of data, we actually have to use sigma and the number of data points and the mean value to determine the error associated with this. Standard deviation, if you imagine a line on a linear graph, you have data points. Let me kind of draw this on a Word doc. So on a graph, I'll try to do this. So let's say we have a graph. All right. And you have a line like this, and then you, let me actually do that backwards. So let's say we have a bunch of dots that are our data, right? And we try to make a trend line. That's not a great trend line. We try to make a trend line that passes through them, okay? Basically what the standard deviation is it's how far away each point is from the average value. It's the difference between the average value or the mean value and the actual point. You square that, you divide that by the actual mean value. So what it does is it becomes like we just did, where it becomes a weighted percentage. That little bit of error squared becomes a weighted percentage of the actual value. You divide, you add up all those squared terms, you sum them all together, divide by the number of data points you have. So basically you get all the error in all the points, divide by the number of data points you have, and you take the square root, and that gives you essentially like an average error per data point. So the standard deviation is all the error associated with your data in a weird way. Does that
Is
make
that
sense?
percentage like an average, or
What was
because every point will have a different like deviation, right?
Right, yeah. And then the standard deviation though is all of it squared and summed together and divided by the square root.
Oh,
I'll put together some stuff for you when we actually have to deal with that next time. But you
okay.
can think of it as the total error. You're going to divide that by n, which is the number of data points, and you're going to divide that, well, actually the square root of n, but that's a stat thing. And then you divide that by the mean to get the error per data point weighted as a percentage of the mean, if that makes sense to you guys.
Yes. Okay.
Yeah, it just shows how far off the data is. It's one way to think of it, which is probably not exactly correct because I'm not a statistician, is it's kind of the total error in your data. And then you're going to weight that and divide it by the mean to get the error per data point. And that gives you the percentage or the error as a percentage of the total. So it's, yeah, it's stats. Stats are crazy. For the second screenshot, what you covered earlier with the down. So Sammy, what was your question about the second screenshot? Oh,
Sorry, I was trying to ask about the second screenshot, like the CSV file. Is that what you were talking about earlier?
yeah,
Is that
just open the CSV file again. I'll open it. Just open it and give me a quick screen grab of that open.
okay? I just want to make sure I understood that. Thank you.
I just want to make sure that, so my whole thing here is I want to make sure that you can use your IOLab device, you can get data off it, and you know where the CSV file is what I want, if that makes sense to everybody. So I know I've talked a whole lot along. I made this way more complicated sounding than it really is. Get your IOLab device up, use the spring to make a nice graph. Let me find this. To make a nice graph of force versus position. And I know that use 2 points and determine the average value for the spring constant. And then I want a screen grab of this, and I want a screen grab of the CSV file once you've opened it and sent it to wherever. So just export to CSV. Go to Documents, IOLab, export, open it up, and just grab a quick screen grab of it. That's all I need though. Yeah. Go ahead. You guys can go and get out of here if you want. If anyone has any questions about anything that I talked about today, and you want to ask them now, feel free. I'll try to answer them for you.
Professor?
Yes, ma'am. Or sir.
So I also had a question about the Wiley Plus account thing. So whenever you're ready, or can I just like share my screen so I can show you what's going on?
Let me, I always leave it off so that someone can like bomb us with something gross. But you should be able to share now if I stop sharing.
Okay.
And anyone else who's here, if you can help us do this, please help.
So basically it's the same thing that I was telling you how like it wanted a code.
Mhm.
So if you can see my screen, this is the like Wiley Plus login. And so when I log in, it automatically just says this section ID. And when I click I don't have it, it doesn't actually go through because I don't have any other information. So basically when I log in, there's no like login dashboard to like see any of the assignments. It just gives me this. But when I go to Canvas and click like open assignment, it allows me to like do the assignment, have access to everything. And then when I go to my grades, it's giving me a grade. So
Okay.
I mean, it's going through Canvas, but I guess not through Wiley Plus. But if it lets me kind of do it through Canvas the whole semester, I guess that's all you need because it will give you the grade.
Yeah, if I have a problem, if I don't see that you turned in an assignment,
Mhm.
or if you check your grade, and you don't have like a grade and you know you did it, let me know right away, and we'll
Okay.
figure that out. I'm obviously not going to penalize you for it,
Mhm.
and if worst comes to worst, we will find another option for you to get the homework done. But it looks like it's working.
Yeah, it looks like it's working just through Canvas, just not through Wiley Plus. But if I'm able to like just get the same exact homework, it doesn't really matter.
Yeah, I don't
Yeah.
know. Has anyone tried like? I'm
Yeah,
assuming we all have.
has anyone just in general like gone past this like course ID thing and like got into a dashboard on Wiley Plus?
Well, I finished
Yeah.
the assignment, but like I don't really know what you're talking about because all I did was I clicked on while or I went on the assignment
On Canvas.
on
Yeah.
Canvas and then I clicked but Wiley Plus practice, finished the assignment, and then it gave me a grade on Canvas.
Yeah, it looks like it's just going through Canvas, not like the Wiley login or something.
So like you don't even have to have an access code.
No, well, I had to sign up before.
Oh, okay. Okay.
I went on to sign up. I went on Wiley Course Resources and then
What I'm worried about is that I somehow just gave you all access to it, which
Yeah.
whoops.
Yeah,
Remember-
it sounds like you don't need access the way it's like being explained, but it looks like you have to sign in even if you have the Canvas link or something like that.
well, you have to do it before you have to do it initially because I remember on the first day of class, remember Professor I was like, oh, I didn't get the 4-digit code. They
Yeah.
sent me that 4-digit code. And then once I signed in, they had me put in the code that I got with my book to actually get the class, you know?
Yeah. I don't know, Sam.
But what do you need it for, Sam? Like, are you trying to?
Yeah, I thought that you need the code to like access the assignments, but I didn't know you can do it through Canvas. But it looks like I'm fine because you can just do it through Canvas. I thought you needed the code, but it looks like
Oh,
if you
meaning
just
you
click
didn't
the
like
link.
actually purchase the like thing or whatever, the subscription?
Yeah, I bought the like code
Yeah.
and I put that in and registered my stuff. But then when I actually log into Wiley Plus, the thing I showed on the screen, that shows up. But it looks like I'm fine because
Maybe
you
it's
just need to have
somehow-
Canvas.
maybe it's got a driver somewhere or a file somewhere that it checked and it's just doing it in the background.
Yeah.
It's weird because when I sign in, like I'm not able to find like the assignment you created, professor, only when I click on the assignment.
Yeah, exactly. That's the thing. Because when you sign in, it brings you to this like Wiley thing. But it looks like if you purchase an access code and you just do your stuff through Canvas and it gives you a grade through Canvas, that's all you're looking for.
Okay. Yeah. If you have any problems not getting your homework done,
Mhm.
then let me know. But
Yeah.
yeah,
And
just
each time you go on or you post the homework, it's going to be posted the same way you've done the Canvas.
yeah, I
Okay.
post it in Canvas under assignment. So you can get a Canvas app for your phone and see it there too. I
Hmm.
don't know if you guys are using your phones.
Yeah.
But when you do, make sure that you click on assignments and make sure you look in assignments. I generally will announce that I've made a homework and when it's due.
Hmm.
But make sure you check under assignments and you don't just look at the homepage. I mean, I
Yeah.
guess I could do a lot more and make really nice little modules each week for you guys, but I don't like doing that.
Yeah, and it looks like as long as you have like a link from Canvas to bring you from Canvas to Wiley, it looks like it's letting you do your homework and it's giving me a grade on Canvas. So that means like Canvas is processing it and
So
everything.
did everyone who's still here, did you guys hear me or read my announcement? This is really super important that you don't mess up your grade. And then I want to ask you, Alejandro, to talk about what you said. But if you don't do an assignment, like let's say you do assignment 1 and you don't do an assignment for the rest of the quarter, if I don't put a 0 in for you, it's going to show that you have 100% in assignments. And then the final week, I put in your zeros and your grade goes dramatically down. I'm going to try and put the zeros in for you. If I put a 0 in, that doesn't mean that's your final grade on that homework or whatever. You might say, oh, I need to get that homework done and I might give you time or I might not, depending on which homework it is and when it is. But if you don't have a grade for an assignment, Canvas may not be calculating it in your grade. So I need to make sure you guys know that so that no one's surprised who has 5 zeros on quizzes or something and their grade goes down significantly if I put zeros in. So I just hope that's okay, that you understand that. I will try to put zeros in as soon as I can, but sometimes I don't. And I just don't want you to be surprised and freak out.
So as long as we do the homework and we see our correlating grade from the assignment on Canvas, that means like from Wiley to Canvas, it's been processed for
Yeah,
you.
absolutely.
Okay.
That's what I see. So if you're seeing
Okay.
a score, then I'm seeing the score as well. Alejandro, yeah, I will, Shota. Alejandro, you said with an access code, it should work, but you can see it through assignment tab.
Yeah, like if you just click on the assignments and like for example, I just started by clicking assignments and went on the one that says Wiley Plus Practice.
Mhm.
I click open and then it just gives me access to the homework.
So is that maybe a trial though?
Yeah,
Where
that's happening with
Yeah.
me too.
okay.
Yeah.
But
So
you
make
will have to
sure,
purchase an access code in order to be able to continue.
okay,
Yeah. So like you have to be signed in.
okay.
Yeah.
Yeah, just if anyone has any issues, actually, if you're doing the assignments and you get a grade and your grade's not showing up, let me know as soon as you can and we'll fix it. Shota, I'm gonna go to my screen, share my desktop.
Professor.
In the IOLab, hang on one second. In the IOLab, let me turn this stupid thing on. I'm just gonna make a record. Stop. Right here, Shota, there's a little arrow. Click on that, export to CSV. when it does that, make sure you look really carefully at where it says it's being saved. Mine is being saved in documents, IOLab work files, export, and then it gives me a file number. So I'm on a Mac, if you guys can't tell that. It's in my document folder, IOLab work file, export, and I can see all the CSV files that I've saved. So all you have to do is then just open one of those and take a quick sniping tool on Windows, as someone mentioned, or screen grab on Mac, which is Shift 4, if that makes sense. Is that cool? Do you understand that, Shota?
Yeah, I do. Thank you.
Cool, awesome. So Sammy wanted a clarification of the Graphing Lab. We make an entirely new Word file. Yeah. No, you can ask me about scientific notation. So what I was trying to get at with the new Word file is you can, in general, use this stuff and just get rid of all this stuff before procedure, and then kind of just rip out whatever you don't need and put in what you need. Unfortunately, on our first lab, and I got rid of my canvas. Unfortunately, on the first lab, I broke it up into there's a file that says data table, there's a file that says table of results. That would all be in one lab report that would have your data table, your calculations, your graphs, the answers to the questions, the table of results, and the conclusion all in one, Sammy. Did that answer that part of your question? Yeah, if you can put a title page, if you're doing it by yourself, I don't need a title page. If you're doing it with other people, please use the lab cover page. I mean, it always looks nice to have a cover page, but if you're doing it by yourself, I don't care if it starts with the data table. I actually like it to have the conclusion up first, because the conclusion is what you did and it makes it read nicer. But I'm going to go through and grade each part of it. Is the data table complete? Does it have all the data? Does it have all the error? Are all the units on it? We'll talk about that next week. And then you had an issue or a question about scientific notation. You can just talk unless you don't want to. Yeah, you want to turn your mic on?
Yeah, I'll try to make it quick, but so say for instance, we have like a number that's like 10.42871, for instance.
Okay, let me, I'm just going to one of these so that I can write. So you were saying,
Make sure. Okay, so the number was like 10.42871.
Yeah. Oh, shoot. Okay. Hang on one second. Okay. You don't want to go get food?
I made myself a sandwich.
Okay. So what was that, Sam?
Okay, so the example number I gave you was like 10.24871.
24871. Okay.
And if I was to make that into a scientific notation of 3 sig figs, that'd just be 10.2 e to the power of 5. Is that correct?
This wouldn't have any, if this number is 10.24871, it would have no e on it. It's just a number. But let's say this number was 1024871. Putting the commas in just so that we can kind of break it up.
Oh, okay.
And you wanted this as 3 sig figs.
Right.
I would write 10.2 and then I have 1, 2, 3, 4, 5. So times 10 to the 5th. Or another way you can write it, and Wiley does this too, is e to the 5. So e to the 5 is another way of rating times 10 to the 5th. Does that make sense?
Kind of, because I was a little bit confused on the Wiley thing because I wasn't too sure with the decimal, like how, like would 1.02 also be correct technically? times 10 to the power of 5?
Yeah, 1.02 times 10 to the 1 or 1.02 E1 should be correct as well,
Oh, okay.
I think.
'Cause it's been a while since I did scientific notation.
Oh, yeah, actually Lucas is right. So if we have 3, it would actually be 1.02 times 10 to the 6th.
Thank you, Lucas. It's been a while for me.
Yeah, I always forget. So
Also, in that first number, Professor, I think he was asking how I know it's just a number, but I think he meant like how would you write it as a scientific number? So it would be 1.2 times 10 to the 6.
I'm sorry. Do you mean the top one or the bottom one that I wrote?
24871.
I'm sorry, I didn't hear that first part because I was talking, Lucas.
No, it's so he like confirmed how you would write that top number as a scientific number.
Yeah.
And then said, oh no, it's just a number. But I think he meant how would you write it in scientific notation? And then I just said it would be 1.02 times 10 to the 6.
I don't know about the 10 to the 6th because if that has a decimal.
Oh
no,
wait, no, 10 to the 1st. Whoa,
Yeah.
sorry.
Yeah, it's okay.
Brain.
We all do it, man. So, and I was thinking, technically, not to be pedantic about it, but you can have like 300 times 10 to the 6th if you want. 300 million is 300 times 10 to the 6th.
Right.
I think it's frowned upon by people who get really annoyed with such things. But I'm going to tell you a secret. If you're talking about, say, light, and light comes in waves that are in nanometers, you sometimes say that things have a wavelength of 300 nanometers or 462 nanometers, right?
Yeah.
That's
And those are really, yeah, I know what you're trying to say. Those are really like, because a nanometer is 10 to the negative 9th meters.
Right.
So
Yeah.
it's technically like the
And the
frowned upon.
wavelength is 10 to the 6th. So it's like, they
Yeah.
go, oh, it's 400, blah, blah, blah.
Is it micro or nano?
I'm sorry. So visible light spectrum is 400 nanometers. So yeah, that's
9.
what is 400 nanometers. 400 times 10 to the 9th is 4
Negative.
10 to the 7th.
Oh no, why would it be?
I'm sorry, 10 to the minus 9.
Yeah.
7.
Nano is negative, right? Or
Yes,
rather- okay.
negative 9. So this is 400 nanometers is 4 times 10 to the 7th meters.
Yes.
Because 400 is actually 4.0 times 10 squared.
Yeah.
So if I plug that in and I multiply that by 10 to the negative 9 as well, these add and I get 4.0 times 10 to the negative 7. But no one ever says 4 times 10 to the minus 7 for nanometers for light. They always say nanometers. The reason why is it's an astronomy thing. They keep everything in nanometers so that things can be in the CGS system, or they use angstroms, but that's beside the point. But like I said, not to be pedantic, you are correct. I think it's best in most cases to write one digit, one leading digit, and however many decimal places you need to maintain the appropriate number of sig figs. So if Wiley wants 2 sig figs, you need to include 2 and then the scientific number.
All right.
Sammy?
Okay. I had another question because I was getting some weird numbers on my homework, but like.
Yeah, if your homework, if Wiley starts giving you an issue, you guys should all know, everyone who's here, if you think you've got it right and it tells you you're wrong, you can contact me, you can text me, you can email me, and we'll go through and see if you're actually getting it right. I don't want you to fight that. If it's marking you off because you've got a weird rounding error or it's not in the right scientific notation, I'll make sure you get points. I'll go back in and give you credit for the answer. I care more about the physics of it than
Yeah,
the Wiley plus wanting things in certain ways. Okay.
Yeah,
Okay.
I was doing the homework and it looks like, especially for rounding and stuff, it's very sensitive with
yeah,
if you have
it
like a
is.
And
dispute.
I
Yeah.
will show you guys when I get it, when I find it. There's a Wiley problem, and I think it's one of the ones I like to give in like chapter 15. It says specifically, do not round your answer before you get to this certain point. And if you go through the solution that Wiley uses to get their answer, they
They
round.
round it, don't they?
Yeah, yeah. And I'm like,
That's the problem with doing like my first calculus teacher at Saddleback would have us do homework online, and it wasn't hard. Like it's Calc 1, but like just having to figure out like how the system wants you to put it in, and but like the important thing, like you said, is that we understand like the conceptual aspect of it.
yeah, and I don't want you guys spending a lot of your time and energy. I mean, you guys are stressed, you're frustrated. I don't want you spending a lot of your time and energy on the frustrating part. I want you learning physics, right?
Okay.
So if I can help you, if you're pretty sure you're doing it right, but the answer is not right, you can always bring it up before class or after class. On Tuesdays, I'll usually have the homework due so that on Tuesday after lecture, you guys can ask me any questions and we can go over any of the homework that you might not have done yet. Okay.
Mm.
And work together. And then worst comes to worst, if you really feel like you're right, every one of these problems is online. You guys know that, right? You can type the question into Google and it'll pop up. So I don't want you to do that because your brain actually shuts off. You kind of get into this pattern of needing to be told the answer. I equate it to like a video game. If you ever played a video game and you're like constantly going online to figure out like the strategy to get through the next level, you stop having fun. You just kind of are just going through the motions and you're not actually learning, if that makes sense. I think that makes sense. Anyway, does anyone else have any questions that I can help them with?
Professor, and just a conclusion with the whole Wiley Plus thing, it looks like as long as I'm signed in and I'm able to access the link through Canvas, it will process everything properly. So if there's any issues in the future, I'll let you know. But for now, it looks like I figured it out.
Awesome. Yeah, with anything, if there's any issues, just let me know. I'm not mean about grades. I will try as hard as I can to accommodate you and figure out an option if something's going weird and wrong on your end. Okay, yeah, what's the actual homework question, Lucas?
So on 3C, I might be right, but I was just having a hard time interpreting the question. It was that like astronomy question with that planet that rotates, whatever.
Yeah, so you were worried about C?
Yeah. How
Okay.
did you?
Now, the big thing that you need to know, and we haven't gotten there yet, is whenever you have error associated with a measurement and then you add multiple measurements, you add the error. So in this problem, it gives you, wherever this stupid homework is, right in front of my face, it gives you this error associated with the time it takes to rotate. If you count really carefully, this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, but it's in milliseconds. So this error is actually plus or minus 3 times 10 to the negative 17. If it rotates, for me anyway, I don't know if your number is different. If it rotates 8 times 10 to the 6 times, I need to multiply that error, that 3 times 10 to the minus 17,
Oh, it's
times 8 times 10 to the 6, which gives me 24 times 10 to the minus 11. So 10 to the minus 17 times 10 to the 6 is 10 to the minus 11. 8 times 3 is 24. So I would get 2.4 times 10 to the minus 10. If you need me to write that out, I can write that out for you.
well. So the plus or minus 3 is it referring to the last
It's the last shown digit. That millisecond is the units, but this ±3, whenever you see that in a scientific paper, it refers to the uncertainty of the final digit. So the 5, the last 5, the 5 on the right here. Might
Okay,
be
I
2,
see.
it might be 8. And then you're in milliseconds. So this is actually the 14th digit. And because you're in milliseconds, you're technically already at 10 to the -3. So this whole thing is 10 to the -17 at that 5th place, or that final place. That is the 10 to the -17 seconds. Does that make sense?
Yes. So, but that's in milliseconds.
Yeah,
though.
it's 10 to the minus, it's 3 times 10 to the -14 milliseconds. And a millisecond is 10 to the -3 seconds. So it's actually 10 to the -17 seconds. 3 of them is the uncertainty. And then you have to do that 8 times 10 to the 6, or 8 million times. You have to add 8 million times. You have to sum.
I'm sorry. I'm still kind of confused. I'm so sorry. I know.
No, no, no,
so-
no. Don't be sorry. So let me do it this way. And I'm going to do something really quick, fast.
Okay.
If I have a ruler and the ruler has 0.05 centimeter error,
Yes.
if I make 3 measures, so I lay it out like 3 times and I measure the total length, I would have to add those all together. So I would get the total error would be 0.15. However, this problem is saying that we're in milliseconds. It's 1.557, blah, blah, blah. I'm gonna leave that for a second. Why did you do that? What are you doing? I don't know what happened. 1.557 all the way down, and that last digit, there are 10 to the -14, and these are milliseconds. Okay, so it's saying the error associated with this digit is ±3. Since they're milliseconds, this is actually ±3 times 10 to the -17 seconds for one observation. We're going to take 8 times 10 to the 6 observations, meaning we're going to have to multiply this error by 8 million, 8 times 10 to the 6. So when we do that, 8 times 3 times 10 to the 6 times 10 to the -17 becomes 24 times 10 to the -11, or 2.4 times 10 to the -10. Does that make sense?
Yeah. For me, it's just 1 million. But
Yeah. Yeah. So it would just be a 1 here, and I would get 3 times 10 to the -11 seconds.
have to multiply for me it's 1 million by the associated error, which is ±3 to the negative. That's in milliseconds. If it was milliseconds, it would be 17. You said -17.
Yeah, I got -17 because I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then there's another 3 because it's milliseconds. So this last digit is 10 to the -17 seconds. That makes
Got it.
sense?
So it's ±3 times 10 to the -17 seconds, right?
Yes, and then you're going to multiply that by 1 times 10 to the 6. So essentially, you're just going to add 6 to
Okay,
the.
I see now. But with the ±3, do you have to write that in or no?
No, no, no. So you can see here on this one, it just took it as 2.4 times e times to the -10. And it has 3 digits there because this has 3 digits.
Okay, I see. I'm pretty sure that's what I did though.
Hmm.
And
I can actually look really fast for you if you don't care.
let me just do it one more time.
Okay.
So 3 times. Yeah, 3, that's what I put in, 3. So I did
So let
3.
me, let me look really fast.
Yeah. So what I did, I just did 3 times 10 to the negative 17 times 1 million.
Yeah. So why? This is sane.
Oh my God.
It wants 3.00. It wants your sig figs.
So 3 point, oh my God.
Yeah, Wiley sucks, man. That's why I also don't take off points
Yeah.
until you absolutely get it all wrong. And even then, if you get a question completely wrong, if you contact me, I'll give you credit for it as long as you know how to do it right. If you want to go over it. So anything that you use all of your guesses on, if you want, we can go over it and I'll give you credit for those questions as long as you know how to do them. The most important thing is that you know how to do these problems, not, you know, stuff like this. Stuff like this infuriates me. It's annoying. So you all good, Lucas?
Yes. Yeah, I spent a little while on that one.
Yeah, you'll kind of get a feel for when you're kind of spinning your wheels and you need to stop yourself from doing that sometimes.
Yeah.
Professor?
Yes.
So whenever we're gonna do like when we're gonna ask questions, after we have submitted them, and there's like a problem where we got it completely wrong, and we go over it in class, will you give credit for that?
Yeah, if you contact me and we talk about it, I will. What I care about is that you do understand. So,
Okay.
yeah.
How do we show you that we understood the problem?
So what I'm saying is if okay, let's say you did this one and you got a 3.7 out of uh, a 3.7 out of the 5, and you just text me or talk to me in class and said, hey, I know how to do it. I just used up all my chances, but then I looked and I knew how to do it. I'll probably just say, just send me the work on it. And if you send me the work by email, I'll go in and give you the points for it.
Oh, we can email you the the new solution.
Okay. So I don't want, 15 every homework.
Right. Yeah, that's why I wanted to ask because I knew it would be a lot.
But yeah, every once in a while, if you want to fix things, if it really boils down to an issue where, like Sammy was having, that, or was it Sam? Sorry, Lucas was having, where it's obviously, if you know how to do it right, and it's not accepting it because you've made some stupid error in your numbers, I want to give you points for that. Obviously, I don't want people to use it as oh, I just blew through it and then it's okay because the professor will give me points at the end for it.
Yeah.
But if you legitimately, are worried about it, or if it's a legitimate issue, like if Lucas had used all of his attempts up and he was like, I really think I knew what I was doing and I should have gotten credit for that, let me know. If you really, you know what I mean, we can work it out.
Yeah. Like the first attempt I did for one of the problems, I put like 0.69 and Wiley marked it wrong. And then the actual answer that I put after that, it like accepted was 0.690. Like it's pretty sensitive if you like have the answer right, but like a wrong sig fig error.
So if you feel that you have gotten that right, or if you're starting to have homework problems and you don't have any, you know that your homework's, you're doing bad on your homework, get with me and we'll fix things and figure out ways that you can submit handwritten solutions, stuff like that. What I mostly care about is that you're doing your homework, and I'll give you credit for doing your homework. So Lucas or Sammy, are you wondering about part B on that question? I'll open that up again, and I shouldn't have closed it.
Yeah, I just want clarification on part A, and I'm a little bit confused on part B because I'm not too sure where to start with that.
Sure. Let me open this and open the homework and we'll talk about it real fast. Why the practice.
The book, I was reading the book and I can find the page, but the book did a problem pretty similar to that. I was kind of surprised.
Yeah. So on, it says some rotate, there's that. How many times does it rotate in 41 days? So what you need to do is divide 41 days in terms of seconds
Yeah.
into, or I'm sorry, divide this into 41 seconds. So let me show you what I divided that.
Okay, so I must
So
have been math error I did then.
41 days in terms of seconds is 24 hours in one day,
Mm-hmm.
and blah, blah, 60 minutes in 1 hour and 60 seconds in 1 minute. And when you do that, I have my calculator, so hold on. So I get 41 times 24 times 60 times 60. And what that gives me is 3,542,400 seconds.
Right.
Then, at least for me, and you're going to have a different number of days, I would then take this 1.557 milliseconds, and I'm just going to use 1.557, divided by 1.557 times 10 to the minus 3, because it's milliseconds per rotation. And that'll tell me how many times it rotates, right? That's what they want to know, how many times, yeah. So once I do that, for instance, for me, divided by 0.001557, I get some big number. I get 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 2.27, 2.28 times 10 to the 9.
I got 2246.290425.
So hilariously, notice that it's actually taking the full number there. The actual number I get is 22751440509. Wiley Plus doesn't need scientific notation there, but it was actually counting Lucas off. But in answer to how you do this is you take the total time in seconds and divide it by the seconds per rotation.
Okay, so I was on the right. I was doing that right. This is mathematical.
Yeah, it's just what they call chain link in the book, or what you probably know as unit conversion.
Right.
You need to turn days into seconds. And then how many times does it take to rotate that many times? Well, that you could just multiply that by the seconds per revolution, right? Or rotation.
So I multiply the 8.00 times 10 to the power 6 in this case by the 1.557.
1.557 times 10 to the minus 3 seconds, because it wants it in seconds here. So you'd multiply 8 times 10 to the 6th times 1.557 times 10 to the minus 3.
Oh, okay. Wait, how do you know it wants it in seconds though? Because that part kind of confused me a little bit.
You can actually, someone else might be able to tell me that. Can you actually change it to milliseconds on your end? I don't know if I can on mine.
I'm not too sure. Let me check. But yeah, you can change it to milliseconds.
Yeah, you can, but it says that the units that you have on your screen are correct.
Yeah.
Yeah.
So
Okay.
it's most definitely in seconds, but I was a little bit confused about how do you know for sure it's in seconds and not I'm trying to say milliseconds.
In general, we want everything. If it's a mass, we want it in kilograms.
Right.
If it's a length, we want it in meters. And if it's time, we want it in seconds.
Okay.
Because a Newton is a kilogram meter per second, and everything you do in SI is in meters, second, kilograms, okay?
Right.
So in general, Wiley, if you don't know for sure, turn everything into seconds and meters and kilograms.
Okay, got it. Thank you.
Is there anyone else with a question? If not, we can get out of here.
Professor?
Yes.
So I was trying to do the file that you told me, or you taught me how to do earlier, and I managed to like export it, but then when I open the exported file, it just opens a Excel spreadsheet.
Are you okay showing me your screen?
Yeah, sure.
You should be able to share it.
So like when I open it, I get something like this chart I just like inserted afterwards.
Yeah, you don't have to actually do that. That's fine that you did. You want to graph column D time versus column F, but you don't have to graph this at all.
So I would just
All I wanted to know was that you could actually get to that CSV file if we need it. I want to make sure that you're able to get your CSV file, just so that I know that you as a student can get your data. You know what I mean?
Okay,
So
thank
you
you.
don't need to do any of this. Just take a screenshot of the actual file in your, that CSV raw data file.
So I don't need to open it. I just need to screenshot the files present.
Yeah, that the file.
Okay.
Yeah.
Got it. Thank you.
Just so I know that you know how to get to your data. That's all I want.
Okay.
Cool. Anybody else? If not, have a great weekend, you guys. It might say in the syllabus that we're doing chapter 2 on Tuesday. We're actually probably going to do vector stuff on Tuesday, which is chapter 3. The reason why I like to do the vector stuff first is once we have it out of the way, we can then start doing physics. It's a little bit of a lot of math that day, but I'm also doing that chapter for my other class on Wednesday. So we're going to do vectors on Tuesday, which is chapter 3. Yeah, Eric. All right, since no one's here, let me stop with my recording and I'll